Hello students, let us start our today's session from the chapter Aldehydes, Ketones and Carboxylic acids. In the last session itself, we have completed some of the chemical properties of carbonyl compounds. Today, we are going to see some more chemical properties of carbonyl compounds. Let us see the first of all nucleophilic addition elimination reactions with ammonia and its derivatives. Carbonyl compound, they have C double bond O group in its structure. So, when this C double bond O, when it reacts with the ammonia or its derivatives, there would be a loss of water molecule and hence we will get such derivatives of the carbonyl compound. So, here first of all it undergoes nucleophilic addition followed by elimination of water takes place and hence we are getting these derivatives from the carbonyl compound. See, this is ammonia, it has 3 hydrogen atom. When one of the hydrogen is replaced by some suitable groups like alkyl hydroxyl or amine, that is NH2 group is amine, or phenyl group, or 2,4 dinitrophenyl group, or an amide group. NH2CO group is called amide group. So when such groups are replacing one of the hydrogen in ammonia, we will get their corresponding products. See, this is called primary amine and in place of hydrogen we are using OH group. So, hydroxyl amine and this is 2 NH2 groups are there. It is called hydrazine. In hydrazine, one of the hydrogen is replaced by phenyl group. So, it is phenyl hydrazine. Or when the phenyl group, it has nitro group at 2,4 position, then it is said to be 2,4 dinitrophenyl hydrazine. It is shortly known as 2,4 DNP. And in the place of hydrogen, if you have an amide group, then it is called semi-carbazide. When carbonyl compound reacts with either ammonia or its derivatives, we will get the respective products. Imine, Schiff's base with the primary amine, oxide with the hydroxylamine, hydrazone with the hydrazine, phenyl hydrazone with the phenyl hydrazine and 2,4 dinitrophenyl hydrazone with the DNP or semi-carbazone with carbazide. Let us see some of the examples of formation of these derivatives now. Let us discuss about how nucleophilic addition and elimination reaction takes place in carbonyl compound. See, this is the carbonyl group. We are taking ammonia or its derivative. Here the Z group is to be attached with the nitrogen and the 2 hydrogen which are attached with nitrogen only will proceed in the reaction. The Z group will be retained in its product itself. See that this nitrogen, it carries a lone pair of electron. And this carbonyl oxygen being more electronegative, first of all it will abstract the proton from the amino group and subsequently the carbon develops a positive charge and hence this lone pair electron attract that electrophilic site of carbon. So we are getting COH NHZ, one of the hydrogen with the oxygen OH group and the rest of the group is bonded with carbon atom. Now on heating, when this compound is heated, there is a movement of proton from the NH group towards the OH group. So there is a formation of H with the OH plus water is produced. As a result of movement of hydrogen from NH towards OH, there would be a double bond between carbon and nitrogen. So we are getting the derivative of carbonyl compound. So first step, the ammonia derivative undergoes nucleophilic addition reaction with the carbonyl group and followed by heating there is an elimination of water molecule between the NH group and the OH group. So we are getting the derivative of carbonyl compound. Here the Z can be, if at all ammonia, the hydrogen, the Z will be hydrogen atom. or if it is a primary amine, the Z group will be an alkyl group, or if it is an aromatic amine, the R that could be even AR group, that is aryl group, or we can take alkyl group. And if the Z group is OH, then the name will be NH2OH hydroxylamine. Or if the Z group is NH2, that makes hydrazine. Or if the Z group is the phenyl C6H5NH group, then it is said to be phenyl hydrazine. Or it is 2,4 dinitrophenyl hydrazine. If CONH2 is present in this, then it will be semi-carbazide. So let us take one example with the acetaldehyde as well as benzaldehyde. When do they react with the primary amine? It is called methane amine, and the other one is called aniline. C6H5NH2 is called aniline. So when acetaldehyde reacts with methane amine, similar how we have discussed over here, same way we have to discuss. So this oxygen takes away the proton from NH2 group, and hence the lone pair of electron on nitrogen that attack that carbonyl carbon. So we are getting this product. Followed by heating, there is the movement of hydrogen from NH towards the OH group. So there is a loss of water molecule, and hence we are getting N-methyl ethane imine. So this is what imine product. In place of methane amine, if we use aniline with the benzaldehyde, it forms same type of reaction. See that the double bonded oxygen that takes away the proton from amine, and the lone pair of electron attract that carbonyl carbon. So we are getting this product. Upon heating, this H and OH is eliminated as water. We are getting benzol aniline. This is the name called benzol aniline. It is also known as Schiff's bases. Schiff's bases are formed only with the benzaldehyde with the aniline, or with the methane amine that forms Schiff's bases. These reactions are usually catalyzed by acid. So the reaction which proceeds in presence of acid. As well as there is an equilibrium existing between the addition product and the reactant. But the position of equilibrium shifts towards the product side as there is a rapid elimination of water molecule, that is H2O. So let us see the reaction of carbonyl compound with hydrazine. Hydrazine NH2 NH2. So here the nitrogen carries the lone pair electron. The doubly bonded carbonyl group, that oxygen abstract the proton, and hence the nitrogen will attract that electrophilic site C+. So we are getting this product. And in this case there is a rapid elimination of water between NH and CHOH group. So as a result of elimination of water, there is a double bond between carbon and nitrogen. So we are getting CH3CH double bond NH2. This derivative is called hydrazone derivative. So as it is formed from acetaldehyde, we can say it is acetaldehyde hydrazone. If at all it is formed from benzaldehyde hydrazone. Acetone, then it would be acetone hydrazone. So only the thing CH3, if at all C6H5, here it will be C6H5. Or if the hydrogen is also CH3 group, then this hydrogen would also be CH3 group. So depends on the nature of the substituent present in carbonyl group, we will get their respective derivatives. The next reaction, let us discuss with the 2,4 DNP test. Carbonyl compounds, when it reacts with the 2,4 DNP, that is dinitrophenyl hydrazine, they used to form a characteristic colored solids like yellow, orange, red solids or yellow, orange colored solids. From the formation of the colored solids, we can identify the compounds may contain the carbonyl group. That carbonyl, even it could be a ketone or even an aldehyde. You know, this DNP reagent is also called as Brady's reagent, an aqueous solution of DNP is called Brady's reagent. And this Brady's reagent, when it is taken with the carbonyl compound, we will get such colored solids as a precipitate. And these precipitates, they have their sharp melting point. From the difference of the melting point, we can identify what kind of carbonyl compound is taken for the reaction. Let us discuss how the reaction proceeds. Just like with the hydrazine, we can proceed the reaction with DNP also. See this carbonyl oxygen with the hydrogen of NH2 group and the lone pair of electron on nitrogen towards the electrophilic carbon, and hence we are getting the product, and it is catalyzed by an acid, and removal of water molecule from the NH group and CHOH group. So we are getting 2,4 dinitrophenyl hydrazone. The end INE will be converted into ONE. So the name will be phenyl hydrazone is formed. So this 2,4-DNP test, that is useful for the detection of the presence of carbonyl group in a given compound. Next reaction with the semicarbazide. Semicarbazide, actually it has 2 NH2 group. So the question, which of the NH2 group will undergo nucleophilic addition reaction with carbonyl? See, the NH2 which is far from that carbonyl group should take part in nucleophilic addition. This is why, because the lone pair of electron present on the nitrogen atom of NH2 group is in conjugation with CO group of carbonyl oxygen. So because of that, the availability of lone pair electron on nitrogen atom decreases, and hence the CONH2 group does not take part in nucleophilic addition reaction. Let us discuss. This will attract the hydrogen atom of NH2 and the lone pair of nitrogen will attack that electrophilic site. We are getting this product, and there is a removal of water molecule. So we are getting the product of semicarbazone. So in the reaction of carbonyl compound with the semicarbazide, the NH2 group of carbazide, which is far from the CO group, only will take part in the reaction. Let us discuss about the semicarbazide, from which of the NH2 group will take part in nucleophilic addition reaction. So out of the 2 NH2 groups, the one is in just nearer to CO group, and here nitrogen carries a lone pair electron and oxygen carries 2 lone pairs of electron. We know well this oxygen is more electronegative than the nitrogen, and hence this oxygen that withdraws the electron from the carbonyl carbon, and subsequently the lone pair of electron just migrating towards carbon nitrogen. So we are getting the resonating structure of NH2NH CO with 3 lone pairs of electron with the negative charge, and doubly bonded NH2 where the nitrogen it gets the positive charge. So the availability of lone pair of electron on this nitrogen is reduced, and hence the NH2 group which is in conjugation with the carbonyl group do not take part in nucleophilic addition reaction with aldehydes or ketones. So such a way we can explain all the possible reactions of carbonyl compounds with all these derivatives, and hence just we have taken very few of the example to explain about nucleophilic addition elimination reaction. The rest of them you can able to practice with any of the derivatives of ammonia with any of the carbonyl compound. We will get the corresponding products. Very important reactions only discussed over here. Let us discuss reactions of ammonia with carbonyl compounds. Ammonia that may react with formaldehyde, acetone and benzaldehyde, it gives rise to different products. Let us see first of all with formaldehyde. Formaldehyde HCHO. So in this case, when formaldehyde reacts with the ammonia, we are getting hexamethylene tetramine. This hexamethylene tetramine actually a medicine which is given for urinary infections. So actually tetraamine we need 4 nitrogen atom and hexamethylene, so 6 carbon atom and 4 nitrogen atoms are present in this compound. So based on that we have to take 6 times of formaldehyde and 4 times of ammonia. So 4 3s are 12 hydrogen, so we are getting 6 times of water molecule, and you may have 6 oxygen from the formaldehyde, so the formula it becomes hexamethylene tetramine. And the structure of hexamethylene tetramine is very important. In this, the nitrogen, all the 4 nitrogen atoms are linked to another nitrogen atom through the methylene groups only. So for between any of the 2 nitrogen you may find the presence of CH2 group. So NCH2, NCH2, NCH2. So it makes a regular hexagonal structure. And inside there is one nitrogen atom is present, and all this nitrogen atom it can link with the 3 more nitrogen atom of the ring through the CH2 group. So NCH2N, NCH2N, NCH2N. So this is the way how to draw the structure, and you may find the presence of 6 CH2 group as well as the 4 nitrogen atom. And this is called the structure of the urotropin. And this urotropin actually used as medicine for the urinary infection, as well as when this compound is nitrated, we are getting the compound, it is called RDX, research and development explosives it is actually. And the compound usually explosive substance, it can also be known as cyclonide. The next reaction of ammonia with acetone. Acetone actually heated with ammonia, where 2 molecules of acetone, it undergoes condensation reaction with ammonia such a way. So 1 oxygen atom of carbonyl group, that is from acetone, with 1 hydrogen atom of alkyl group from the acetone and 1 hydrogen atom of ammonia. You may find there is a formation of water. So here the doubly bonded carbon, it gets linked to NH2 group and CH2CO, a CH3 group. It is called, this is one acetone, this is one acetone. So the name is diacetone and it is called amine. So the name of the compound is diacetone amine. So with 2 molecules of acetone, it condensed with 1 molecule of ammonia to give diacetone amine. With benzaldehyde, there are 3 molecules of benzaldehyde taken with 2 molecules of ammonia. So you may find there is the condensation between the aldehyde and amine. We get hydrobenzamide. See here 1 molecule of water, here 1 molecule of water, H2O. So there is loss of 3 molecules of water as a result of the C6H5CH double bond N. C6H5CH double bond N, and these 2, the carbon with the double bond, it links with both of the nitrogen atom, so we are getting hydrobenzamide as the product. That's all the reactions of formaldehyde, acetone and benzaldehyde with ammonia. Haloform reaction. Haloform reaction is actually useful to detect the presence of methyl ketone group. The methyl ketone group is denoted as COCH3 group. Usually the COCH3 group will be present at one end of the given compound. So always COCH3 that becomes the terminal group of the carbonyl compound. So when this methyl ketone is treated with sodium hydroxide with the halogen, or when halogen is reacting with the sodium hydroxide, usually it forms sodium hypohalide, NaOX, where X that might be either chlorine or bromine or even iodine. So this is a mild oxidizing agent. First of all, the given group, the methyl, the alkyl part, it gets halogenated. So in this case, the methyl part, it has 3 hydrogen atom. All of the 3 hydrogen atom will be halogenated. So it becomes CX3 group. followed by treatment with the base that forms the carboxylate group and the haloform. So let us discuss, and in this case the R group, it might be either C6H5 group or CH3 group or CH3 the acetone part also. But at the same time, the reaction that can be answered for primary alcohol, that to ethanol alone, and the isopropyl alcohol, because this oxidizing agent that can oxidizes the primary alcohol into CHO as well as the CHOH into CO group. So when it goes CHO, you are getting acetaldehyde. When it goes CO, you are getting acetone. So in alcohol, you can have either ethanol or isopropyl alcohol or 2-propanol. That will also answer for haloform test. Besides this alcohol, the acetophenone or acetaldehyde or acetone or any compound that contains COCH3 group will answer this test. So let us take an example. Any carbonyl compound having COCH3 group is treated with the halogen in presence of a base. This methyl group first of all chlorinated. All the 3 hydrogen atoms are substituted by 3 halogen atoms. So there would be a loss of 3 hydrogen halide. So we are getting trihalocarbonyl compound. Followed by treatment with the sodium hydroxide, you may find there is a formation of RCOONA, that is RCOONA, salt of carboxylic acid will be formed, and CH3 with the hydrogen that forms CHX3 known as haloform. In this haloform depends on the presence of a chlorine atom or the bromine or the iodine. We can get the corresponding chloroform, bromoform or iodoform. So this is a very important test, and this test usually explained in word problem. So in this word problem, if at all they have given, it gives positive test with the haloform, you have to consider then that given compound has COCH3 group. So this is also be taken as the hint for word problem. Most important reaction of carbonyl compound is aldol condensation reaction. This aldol condensation reaction is only possible where the carbonyl compounds having alpha hydrogen atom. Already we have discussed about alpha, beta, gamma position when we have that nomenclature topic. So the functional group aldehyde that attached with the carbon is said to be alpha carbon, and that alpha carbon carrying hydrogen atoms are alpha hydrogen. So the reaction to be carried out in presence of a dilute base. The base is useful to generate the nucleophile, that is the carbon having the negative charge known as carbanions. And this carbanion subsequently that attacks the electrophile of another carbonyl compound of either same carbonyl or the different carbonyl. We will get the alkoxide ion. This alkoxide ion followed by protonation, we will get aldol. So what do you mean by aldol? See this ald, that is the part of aldehydic name, and OL, that is the part of alcohol. That means the product it possesses the 2 functional group, one is aldehyde, the other one is alcohol. So that is called aldol. And the formed product upon heating, it may lose a molecule of water, that is the condensation reaction takes place between the alpha carbon and the alcoholic OH attached carbon. We will get an unsaturated carbonyl compounds. Let us discuss about the reaction of acetaldehyde. Here I have taken both the aldehydes are similar. When both of the aldehydes are same or the ketones are same, those are said to be simple aldol reaction. So in this case, there is one molecule acetaldehyde, other molecule also acetaldehyde. Out of these two, one I treat it as nucleophile. Nucleophile must carry the alpha hydrogen. So this is the functional group. The functional group attached carbon is alpha carbon and it has 3 alpha hydrogen atom. So one of the alpha hydrogen is just attracted by the oxygen of the other carbonyl group. So we are getting OH group. So as soon as the oxygen attacks that alpha hydrogen from the adjacent molecule, then this CH2 group will attack the carbonyl group of this one. So we are getting CHOH, CH2, CHO. So we have both alcoholic group as well as aldehyde group in its structure. That's why the name is simply ALDOL. So how will you name that? It is functional carbon, it is alpha carbon, this is beta carbon, this is gamma carbon. To the beta position we have OH group. So what you will say? Beta hydroxy 4 carbon in the structure, so it is butyraldehyde. Upon heating, there is a loss of water molecule between the alpha beta carbon. From the alpha carbon, one of the hydrogen, and from the beta carbon, the OH group that is removed as water. At that time, you are removing the 2 groups between the adjacent carbon and hence you are getting the double bond. So as a result of aldol reaction, we will get beta hydroxy derivative. On heating, there is a loss of water molecule between the alpha beta carbon. We will get that unsaturated carbonyl compound. So let us discuss about the mechanism involved in the reaction. The first step, what I told you, it is the generation of nucleophile. The nucleophile can be generated only in presence of a dilute base. So base that provides OH minus ion. So this OH minus that abstract the proton from the alpha carbon, where we will get minus H2O and CH2CHO. So H2O and CH2CHO is formed where carbon carries the negative charge. So it is a nucleophile as well as it is carbene ion. And this carbene ion, it attacks the another molecule of carbonyl compound. So how many carbonyl we have? 2. Both of them are acetaldehyde. So one of the acetaldehyde is converted into carbene ion. This carbene ion should attack the another acetaldehyde. So we have taken the second molecule to which only the reaction is going to take place, where the carbon develops the positive charge. That's why the second molecule of carbonyl can be treated as electrophile. So the nucleophile attacks the electrophile such a way. See, oxygen withdraws the electron and this negative charge carbene ion attacks the electrophilic site. We are getting alkoxide ion. Alkoxide, this is an alkyl part with the oxygen negative charge. So it is an alkoxide ion. And this alkoxide ion gets protonated from the water. Here we have water molecule as one of the product formed. From this water, this alkoxide ion that removes the proton. So we can have the removal of proton from the water. So we will get CHOH minus OH minus ion. See, the base is generated, that is NaOH is taken as the catalyst, and hence the catalyst is regenerated at the end of the reaction. We are getting beta hydroxy butyraldehyde. Upon heating, there is a loss of water molecule between this beta carbon and the alpha carbon. So we will get CH double bond CH, CHO. So here 1, 2, 3, 4. The second position has the double bond. 4 carbon are there. So it is but-2-ene-al and its common name is crotonaldehyde. Cross the aldol reaction. In this, we can have the 2 different aldehydes, or one aldehyde, one ketone, or one formaldehyde, one other aldehydes, or even ketone. So why do I say specifically formaldehyde? This formaldehyde, it has no alpha hydrogen atom because the CHO group is attached with only the hydrogen. So the compound without alpha hydrogen should always be taken as electrophile. So this behaves as electrophile. and the other carbonyl having the alpha carbon and alpha hydrogen is the nucleophile. So in presence of formaldehyde, the formaldehyde should always be electrophile, and the other any carbonyl, whether acetaldehyde or acetone, they should behave as the nucleophile. So same reaction we can proceed. That oxygen with the hydrogen of alpha carbon and the CH2 carbon ion attacks the electrophilic site. We are getting beta hydroxypropanol because it has only 3 carbon atom. And upon heating, there is a loss of water molecule between the alpha carbon and the beta carbon. So we are getting the product propanol. And one more thing, you can confirm the product whether it has all the carbon atoms of both involved carbonyl compound. See, formaldehyde, it has 1 carbon, and acetaldehyde, it has 2 carbon. So my product will have 3 carbon atom. Whether in unsaturated or even in hydroxyaldol derivative, we will find the same number of carbon atom as that of their reactant. Now let us take another example. One I have taken acetaldehyde and other one it is propanaldehyde, or it is propanol and it is ethanol. So in this case I will expect to get 4 different products. Why 4? Because the similar aldehyde, acetaldehyde, it undergoes aldol reaction with its own acetaldehyde. So one product will be formed, and propanaldehyde will react with its own propanaldehyde. I will get another product. And the third product, in which acetaldehyde reacts with propanaldehyde, where propanaldehyde will have a nucleophilic site. And other case, the propanaldehyde will become electrophile and acetaldehyde goes to nucleophile. So there I will get 1 product. So anyhow, if these two are undergoing cross, I will get totally 5 carbon in my product. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. I got 5. Or if they undergo self-aldol reaction, see, acetaldehyde undergoes self-reaction with its own, I will find 4 carbon atom. Or propanaldehyde undergoes self-aldol, I will find 6 carbon atom. So this is, first of all, we should know how many carbon to be there in my product and how I wrote all this product. How? Nothing. You have to fix in your mind which of them is taken as electrophile, which of them is taken as nucleophile. So in this case, the 3 carbon having the group is taken as nucleophile because this is alpha carbon for me and this is, it is beta carbon. So acetaldehyde is taken as electrophile and the propanaldehyde is taken as nucleophile. Okay, in the propanaldehyde, which is alpha carbon? This is functional carbon. This is what alpha carbon, and the CH3 group, it goes beta carbon. So to the alpha carbon I have written the beta carbon. So now this carbon, it has 2 hydrogen atom. Actually we are removing the water from the alpha carbon and the beta carbon. Beta carbon will provide only the OH group. Alpha carbon will provide the hydrogen which is required for the formation of water. See that this carbon, it has 2 hydrogen atom, and this 2 hydrogen atom is being removed as water with this acetaldehyde. So I can write CH3C double bond OH plus CH2 CH3 CHO. I can write first step is with the dilute NaOH and the second step is heating. See that I can remove a molecule of water. So my product CH3 CH double bond CH3 CHO. So in this case, propanaldehyde is nucleophile, acetaldehyde is electrophile. So this product is formed. The next product, this one. Here acetaldehyde is behaving as nucleophile, propanaldehyde is behaving as electrophile. So what should I do? I can take propanaldehyde CH3 CH2 C double bond OH From acetaldehyde, I have H2CH, CHO. This is alpha carbon. From the alpha carbon, I should remove 2 hydrogen atoms. So 2 of the hydrogen with this one, we are getting water. First step in presence of a base, and the second step is on heating. So I will get CH3, CH2, CH double bond, CH, CHO. So here we are getting this second product. This is the first product we got. And the next one, self-aldol reaction. Self-aldol, one is the nucleophile, the other will be the electrophile. So my product CH3, C double bond O with hydrogen plus H2, CH, CHO in presence of a base followed by heating. You can remove a molecule of water. So the product is CH3, CH double bond, C, H, CHO, because both of them are acetaldehyde. So I will get 4 carbon in it. So third product we achieved. And the fourth product, propanaldehyde undergoes self-aldol reaction. So we can write CH3, CH2, C double bond OH plus H2, C, CH3, CHO. From this you can remove a molecule of water. First step with the base, second step heating. So we will get CH3, CH2, CH double bond, C, CH3, CHO. That's all. So crossed aldol reaction is so simple to understand. First thing, you have to fix which is nucleophile, which is electrophile. From the nucleophile, the alpha carbon, you have to remove 2 hydrogen atoms. And from the electrophile, you have to remove only the carbonyl oxygen. So carbonyl oxygen, when you remove, you can retain that double bond. So this double bond is just add with the rest of the molecule, you are getting the respective products. So you can make this reaction even with the acetone and acetaldehyde. So both will have 5 carbon. So once again you will get acetone with the self-aldol reaction, acetaldehyde with the self-aldol, and acetone as nucleophile, acetaldehyde as electrophile, and the fourth one, acetone as the electrophile and acetaldehyde is as the nucleophile. So you will get 4 products. But in the previous case, this formaldehyde, it has no alpha carbon. So only one product only we can expect. That's all. Aldol reaction, crossed aldol reaction, very simple. You can write by imagine. Your imagination is very important. From where you are going to remove the molecule of water, that you have to decide. So first of all, you have to fix which is alpha, which is beta. So alpha, beta carbon only the water to be removed. This we should know. Based on that only you can get the correct product of the combining reactants. Next one, CANNIZARO reactions. CANNIZARO reactions just opposite to that of aldol reaction. Aldol reaction, that carbonyl compound must have alpha hydrogen. CANNIZARO reaction, they should not contain alpha hydrogen. Aldol reaction catalyzed by dilute alkali. CANNIZARO reaction is catalyzed by concentrated alkali. And in CANNIZARO reaction, that undergoes oxidation and reduction. This is also can have the simple CANNIZARO reaction as well as crossed CANNIZARO reaction. So when we have simple CANNIZARO reaction, those reactions are also known as disproportionation reaction. The disproportionation means the same atom that may undergo both oxidation as well as reduction. So simple CANNIZARO reactions are also known as disproportionation reaction. So during CANNIZARO reaction, one of the carbonyl compound will be oxidized to their carboxylate, that is salt of carboxylic acid will be formed, and the other carbonyl compound should undergo reduction, and being aldehyde, it forms only the primary alcohol. So let us have formaldehyde. See, formaldehyde, it has only CHO group and it has no other alkyl group. So So it does not contain alpha hydrogen atom because no alpha carbon. So when both of them are similar aldehyde, this is said to be simple CANNIZARO reaction. In presence of a base, one of the aldehyde reduced to CH2OH. Already it has one hydrogen, so that becomes CH3OH. So you are getting primary alcohol. And the other aldehyde that undergoes oxidation. Aldehyde reduces to primary alcohol, other aldehyde oxidizes to its salt, that is HCOOH will be formed because of the presence of base. The acid reacts with the base to form salt, so it gives sodium formate. Similarly, we can have even benzaldehyde. Two molecules of benzaldehyde taken, so both of them you can refer as simple CANNIZARO reaction. So in this case also, one of the aldehyde reduced to its primary alcohol, and the other aldehyde is oxidized to carboxylic acid, and with the sodium hydroxide it forms sodium benzoate. So we are getting benzyl alcohol and sodium benzoate as the product of CANNIZARO reaction of benzaldehyde. So in both of the cases we find similar aldehyde. If you have two different aldehydes, see one is formaldehyde, other one is benzaldehyde. Here one of them will be oxidized, the other will be reduced. The question, which will undergo oxidation, which will undergo reduction? Oxidation always restricted for bulky groups, but a simpler group readily undergoes oxidation. So out of this formaldehyde and benzaldehyde, this formaldehyde it has the simplest hydrogen. That's why the simpler group oxidized to the sodium salt of formic acid, and the bulky group of phenyl that reduces to benzyl alcohol. So when you find the crossed CANNIZARO reaction, you have to identify first of all among the aldehydes which is the simpler one. That simpler one only should undergo oxidation followed by the reduction of the bulkier one. That's all CANNIZARO reaction. Let us discuss about the mechanism involved in CANNIZARO reaction. Mechanism of CANNIZARO reaction. This CANNIZARO reaction, it involves two simple carbonyl aldehydes. Those do not contain alpha hydrogen, or the different carbonyl, that is the formaldehyde and benzaldehyde may also have. We are going to discuss about the mechanism for simple CANNIZARO reaction. So here the CANNIZARO reaction takes place between the two molecules of benzaldehyde. We will get benzoic acid and benzyl alcohol. So reaction is a base catalyzed reaction. So the first step, it involves attack of the base on the carbonyl carbon of one of the compound. See, I have taken benzaldehyde in which the OH group attack that carbonyl carbon due to the removal of pi electron by the most electronegative oxygen atom. So we are getting C6H5 oxygen with the negative charge with the COHH. It is hydroxy alkoxide ion. The second step, from this ion you have to transfer the hydride to the another molecule of carbonyl, that is benzaldehyde, because we are taking two similar benzaldehyde molecule. So in this case you have to find the transfer of electron among the carbonyl oxygen as well as the hydrogen. Here when this negative charge is moving just towards the carbon, what happens? The valency of carbon increases, and hence the hydrogen withdraws the electron to attack the carbonyl carbon, where this oxygen is most electronegative and hence it withdraws the electron. So the three different movement of electron takes place among these two molecules, and hence you are getting C6H5, the single bond into double bond. So we have COOH, we got the product, and in this case this is CH2O minus. So we are getting benzyl oxide ion and carboxylic acid. This is benzoic acid and it is benzyl oxide ion. We need to have benzyl alcohol. So what happened from the benzoic acid, this proton will be transferred to benzyl oxide ion. So we will get sodium benzoate and benzyl alcohol will be formed. Here we can find the proton exchange takes place between acid and base. Which is acid? This is acid. Acid is benzoic acid, and this oxygen having the negative charge, and it is alkoxide ion also, that is even aryl alkoxide ion. It is a base. It is. So from this acid and base, a proton is transferred such a way. See that this minus, it attacks this hydrogen. So the bond between them will be moving towards the oxygen. So we are getting C6H5CO O minus and C6H5CH2OH. So we are getting benzoate ion and benzyl alcohol. So this is what the mechanism involved in CANNIZARO reaction. So you have to understand how the steps are proceeding. The first step is attack of base to the carbonyl oxygen. So we are getting hydroxy alkoxide ion. And from this alkoxide ion, a hydride ion will be transferred to another benzaldehyde molecule. This transfer of hydride ion to the another benzaldehyde takes place in slow manner. So from here you are getting an acid and the base. From the acid and base, a proton is transferred from the alcohol, that is the carboxylic group of COOH, to the O minus. So we are getting benzoate ion and the benzyl alcohol. That's all the mechanism involved in CANNIZARO reaction. Some more important reactions of benzaldehyde, let us see now. First reaction, CLAISEN-SCHMIDT reaction. This CLAISEN-SCHMIDT reaction is actually crossed aldol reaction. So in which one of the compound will contain alpha hydrogen, the other one do not contain alpha hydrogen. We have seen that crossed aldol reaction with the formaldehyde and acetaldehyde. Here in place of formaldehyde, if you have taken benzaldehyde with either acetaldehyde or with the acetone, then the crossed aldol reaction is termed as CLAISEN-SCHMIDT reaction. So in this both acetaldehyde as well as acetone, they have alpha carbon, as well as there is a condensation reaction takes place between the benzaldehyde and acetaldehyde with the dilute NaOH. So you will get C6H5CH, CH, CHO. So we are getting cinnamaldehyde. The name of the compound is cinnamaldehyde. Similarly with the acetone, you may have CH3CO, CH3, both of them are alpha carbon. So any of the alkyl group from which you can remove a molecule of water, so we will get benzol acetone. So the name of the product obtained is called benzol acetone. So these two reactions are referred as CLAISEN-SCHMIDT reaction because these reactions performed by these people. That's why the name is given. Benzyne condensation. Here two molecules of benzaldehyde undergoes condensation, but in presence of alcoholic potassium cyanide. CANNIZARO reaction, two molecules of benzaldehyde, but that undergoes disproportionation reaction in presence of concentrated alkali, either sodium hydroxide or potassium hydroxide. But in place of alkali, if you take alcoholic potassium cyanide, then the reaction it undergoes just an addition of the molecule. See, the movement of hydrogen takes place such a way. So we will get C6H5CHOH CO C6H5. So this bond, the CH bond becomes between the bond of carbon-carbon atom. So you are getting benzyne. Actually the mechanism describes the different, but just for understanding purpose I am saying one of the aldehydic hydrogen is moving towards other carbonyl oxygen. That's why we are getting CHOH. So this compound is known as benzyne. The next reaction is PERKIN'S reaction. In this, benzaldehyde reacts with acetic anhydride in presence of sodium acetate. So, acetic anhydride CH3COO, Actually, here there is a formation of water takes place because it undergoes condensation. This water molecule, now it just breaks this here. So, you are getting H and OH over here. So, what you will get? C6H5, CH, double bond, CH, COOH. So, you are getting cinnamic acid. See that CHCHO, cinnamaldehyde. Here CHCOOH. So, the name is cinnamic acid. Along with that, we will get CH3COOH because CH3COOH acetic acid formed. In Navier-Stokes reaction, benzaldehyde reacts with malonic acid. This is a dicarboxylic acid, CH2COOH twice. In this, you may find the formation of water between the benzaldehyde and malonic acid upon heating in presence of pyridine. See here, we are getting C6H5CH, COOH. So, a dicarboxylic acid is there, but both of them attached to the same carbon atom. Upon heating, there is a loss of carbon dioxide. We will get C6H5CH double bond, CHCOOH. Once again, cinnamic acid is formed. So, both Navier-Stokes reaction as well as Perkin's reaction forms cinnamic acid, but Perkin's reaction, it deals with the acetic anhydride in presence of sodium acetate, but in Navier-Stokes reaction, benzaldehyde is treated with the malonic acid in presence of pyridine. Formation of malachite green, a green dye is formed. When benzaldehyde is treated with the two molecules of NN-dimethyl aniline. So, to the NN-dimethyl aniline, the para position of hydrogen atom gets condensed with the benzaldehyde, carbonyl oxygen. So, there is a loss of water molecule and the reaction is carried out in presence of concentrated sulfuric acid as a dehydrating agent. It forms malachite green. So, to form malachite green, you require benzaldehyde with two molecules of NN-dimethyl aniline. Aniline is C6H5NH2. So, in this, the out of 2 hydrogen replaced by 2 methyl group. That's why the name is NN-dimethyl aniline. Electrophilic substitution reactions of benzaldehyde. Benzaldehyde in which the aldehyde is the functional group. See, carbon-carbon bond is present in the ring between the functional group as well as the benzene ring. So, because of the two carbon atom which are attached directly, there is no difference in their electronegativity. But in the aldehydic carbon, the oxygen is more electronegative than this carbon. So, oxygen withdraws its electron and hence decreases the electron density of this carbon atom. So, it requires the positive charge. So, to cancel the positive charge, the pi bond of the benzene ring, it moves towards the carbonyl carbon. So, we are getting a double bond. As the electron removed from the second carbon, it takes the positive charge. Now, this positive charge will be attracted by the adjacent pi bond. So, this pi bond that moves towards the positive charge, now the fourth position of the carbon acquires a positive charge. And now this pi electron that moves towards the positive charge. So, the sixth position of the carbon acquire positive charge. And later on this bond will come inside and here that moves, we are getting benzaldehyde. So, in these resonance structures, we may find the formation of positive charges at 2, 4, 6 position. But electrophilic substitution reaction takes place with the electrophile, a positively charged group. So, this positive charge will repel with the electrophile also. The substitution takes place where 2, 4, 6 are occupied by positive charges. So, the two places, the two carbon without charges, only the third carbon and the fifth carbon are free of charges, and hence the nuclear electrophile that may attract that benzene ring to the meta position. So carbonyl groups are generally termed as meta directing group. This carbonyl, either aldehyde or ketone or even carboxylic acid, they make their incoming electrophile to the third position of the ring only, that is called the meta derivative. So in benzaldehyde you can have nitration, sulfonation, even halogenation. During nitration we have to take that nitrating mixture, concentrated nitric acid and concentrated sulfuric acid. So this meta hydrogen with this OH minus H2O, we are getting meta-nitrobenzaldehyde. With the sulfonation, once again this hydrogen with the OH minus H2O, we are getting meta-benzaldehyde sulfonic acid. With the halogenation, you are getting meta-chlorobenzaldehyde. But this halogenation requires the catalyst because the aldehyde group is deactivating the benzene ring. Due to the deactivation, it requires the catalyst. That's all the electrophilic substitution reactions of benzaldehyde. Formation of benzyl chloride. In this, if the benzaldehyde is treated with the halogen, in the absence of catalyst like ferric chloride or aluminum chloride, then the reaction will take place in aldehydic group, not in the ring. So you may have the loss of HCl from the carbaldehyde, from the aldehyde and the halogen. So we are getting benzyl chloride, C6H5COCl, that is said to be benzyl chloride. Students, we have completed the chemical properties of carbonyl compounds. We discussed so many reactions. Even today's session, we have completed ALDOL reaction, CANNIZARO reaction, Haloform reaction and some important name reactions of benzaldehyde along with the electrophilic substitution reactions in benzaldehyde. Okay, let us continue our next session from the same chapter, carboxylic acid. Until then, bye bye.